I'm Sam, and I'm an OpenSciEd teacher and facilitator. And today we're here to talk about the lesson 11 from the bath bombs unit. Now, this lesson is super important and might just be the key to the whole unit. So I kind of want to break it down piece by piece for you. So let's take a look together. How did we get here? In lesson 10, we figured out some really important things. We figured out that when we added energy from a battery to water, we got two different gases with different properties. We also figured out that the particles that make up those two gases are different from one another and different from the ones produced when we heated water. But we know that all of the particles produced came from water. So all of the stuff or all the gases must be made from the stuff in water. So now we're wondering, how do Dalton's models of the particles that change in a reaction compare to the ones that we developed? Let's take a look at a lesson at a glance to see how we're going to get the students to answer this question. This lesson is an investigative lesson. It takes about 2 days and requires about 20 minutes of prep time. There are no hands-on investigations in this lesson. We start day 1 in a science circle to revise our key model ideas about what might be happening to particles during a chemical reaction based on what we learned in lesson 10. We compare what we have learned about particles to what Dalton's and his colleagues learned about particles as well. We end the day by revising our particle model to show that particles are made of atoms and molecules using what we figured out from the Dalton reading. On day 2, we begin by finishing revising our models that we started the day before. We look at other models of molecules, specifically of water, that other scientists have made in order to understand scientific notation. We then look at molecular structures of other substances, most that we recognize from the bath bomb. And we realize that we can use these molecular structures to determine the gas from the bath bomb and end the day by revising our explanation of the anchor phenomenon. We figure out a lot. We figured out that molecules are made of atoms and that all substances in the world are made of only a few types of atoms. We know or figured out that the same substance is made of the same type of molecules or atoms throughout. And we also figured out that in a chemical reaction, the particles that make up the old substances can be broken apart, and the atoms that make them up can be rearranged to form new molecules to make new substances. Let's take a look at a few key moments that will help us to get through this lesson efficiently. On day 1, we begin with the navigation. Now, this navigation time is super important. You really want to plan for this discussion, and there are prompts that you can use in the teacher's guide to help you. You want to begin by having your key model idea poster on the board or somewhere easily able for your students to be able to see, because you want them to look at this key model idea that we had made in lesson 8. We also want to have our poster of what we think particles of the bath bomb might be doing to create the gas. Now, this question or this discussion that you're about to have, it's really important that we want to use this time to press students' ideas about what is happening at a particle level, specifically discussing what we figured out in lesson 9 versus what we figured out in lesson 10. So what are particles doing when we have pretty much like a physical change, but we're not going to use those words, versus what are particles doing when we have a chemical reaction? Okay, and again, we're not using those words yet, but we want to press our students to get to those ideas. We're going to update our key model idea at the very end of the circle based on what we think particles of water are doing when we run electricity from a battery through water. Now, this discussion may take more than 10 minutes. Now, that's what's suggested in the teacher guide, that it takes that long. But if it takes longer, I want to give you permission that that's okay, because it is super important that we're getting our students to the idea that particles are breaking apart and rejoining back together. And that must be what's happening in the bath bomb. In parts 2 and 3, we're still on day 1. We want to compare what Dalton figured out to what we've figured out. So we really want to focus our students on that question. Have students keep this reading readily available and able to call upon for students to refer back to it throughout the rest of this lesson. Okay, so this is not a one and done. We're going to come back to this frequently. In fact, students have found this article so important at times in my classroom that they have suggested that parts of this reading should be added to the Key Model Ideas poster. In part 5, and this is at the end of day 1, we're going to use atoms to revise our class particle model. Now, the purpose of this lesson, or this part, is to make new models. We were originally thinking that the bath bomb is made of particles of water, citric acid, and baking soda. But from the Dalton reading, we figured out that particles don't really exist. We have these things called atoms and molecules. So we need to revise our models. We're going to use the ideas of inputs and output. And I literally have my students write these words right on the worksheet that you can get at the OpenSciEd website so that they begin to use these terms inputs and outputs, and it helps them to start to understand what's happening during chemical reactions. As you are doing this, there are prompts in the teacher guide to help you with this discussion. In part 9, and this is at the end of day 2, what you're going to do is we're going to have the students review what we know about substances. On the OpenSciEd website, there's a handout that looks like the one pictured here. What I do is I give each of my students their own copy. Now, I'll give it to them in black and white. We don't need to make a whole bunch of colored copies, okay? But it's really important that they're able to annotate this. Give them some time in their small groups to make sense of the document that's in front of them. And they're going to start to realize, like, oh my gosh, we know these substances. They're the ones that are in the bath bomb. Bingo! So as soon as you start to hear that, you're then going to ask the students to take a quiet moment to put a star next to the substances that cause the gas to form. Now, don't tell them the answer. Let them do this on their own. They should be putting a star next to citric acid, baking soda, and water. Then ask the students to circle the substances we thought might be the gas. They should be circling, and again, don't tell them the answer. Let them do this on their own. Argon, carbon dioxide, and nitrogen. Now, you're going to ask this really important question. You're going to ask them to look for patterns in their data. Compare the gases to the substances that we started with. Compare our inputs to our outputs. And I want you to look for patterns. Based on what we figured out, which gas is it and how do you know? You're going to have a lot of those mind-blowing moments right now. They're going to figure it out on their own. Like, trust in the process that they can do this, but don't let those students yell out the answer. For example, I might say something like, when you know the answer, touch your shoulder, or point to something in the classroom, and then let them talk in small groups to explain it to each other, and then have a whole group conversation about it. That's really important that we give students that time, though, because remember, not everybody learns at the same pace. Give them some time to figure it out on their own. So what are some tips and tricks to get my students to those mind-blowing ideas that they're going to come to in this lesson, where they're going to start to put things together? All right. On day 1, in part 5, we ask the students to revise the model. Now, I know that the teacher guide calls for a sign circle, but this may be one time that you don't use it, because the modeling takes a lot of small group work. So just consider that. You may want to ask the students to work in small groups. Have the small groups work at one model or row at a time before calling everyone back together to come to consensus. Coming to consensus is super important, though. This may even include having students come to the board to show their ideas and having the class give feedback on the models that they're making. While making the models, have students cite evidence from the Dalton reading to justify the models that they are making. All right, we are at the end of day 2, and this is the last part of day 2. This is where we're going to ask our students to use molecular models to revise the anchor phenomenon routine. Okay. So the teacher guide calls this out as an assessment. Now, you may want to consider not grading this assessment. Instead, something I do in my classroom is I have the students work together to give each other peer feedback on each question. So you're going to go to the OpenSciEd website. You're going to print out the handout that goes along with this part. There are 4 questions for this assessment. This is going to pick up right at the end of part 9, where the students have just figured out what gas is coming from the molecules in the bath bomb and the water. All right, so you're going to give the students the paper. You're going to ask them to answer just question 1. Give them no more than 5 minutes to answer it. Then once the time is up, pass their papers, have the students give peer feedback to each other. You're going to repeat that process for questions 2, 3, and 4. Now, I really want to focus on question number 2 right now. In question number 2, we ask the students to make models. You're going to repeat the same process, and as you look around, you're going to notice that students are drawing very different things. And the students, you can ask them when the time is up to look around, and they're going to notice the same thing. So in order to help them come to consensus about what we could be drawing to show what the molecules of baking soda, citric acid, and water are doing to create the gas, you may want to consider using some form of a manipulative. For example, what I use in my classroom are these paper cutouts, but I've seen people use bingo chips or magnets that you can buy on Amazon. There are tons of resources that you can use, and you can do this in lots of different ways. What you're going to need to do, though, is you're going to need each group, whatever you consider a group, enough atoms to make 1 molecule of baking soda, 1 molecule of citric acid, and 1 molecule of water. And you're going to ask the students to use these atoms. They'll build the molecules and then show what the atoms do during a chemical reaction. Have them show each other, use the key model idea to help the students to figure this out, because this is really an aha moment for some of the students to really start to connect the key model idea to a physical model of what is actually happening. And that's going to strengthen their understanding of what is happening at a level so small that we can't see during a chemical reaction. Word wall management. There are lots of words the students are going to earn. Atom, molecule, chemical reaction, phase change, chemical process. Remember that we want our students to be defining these words and to add some sort of image. A lot of my images, and you may want to consider, come from the Dalton reading to help strengthen and solidify the understanding of these words. Poster management. There are 2 posters, and these we made in lesson 8 that you're going to want to refer to throughout the lesson. Make sure that both of these posters are posted somewhere where it's very visible and readily accessible for students to be able to see. This lesson can seem like a beast, but it is really where the students start to have those mind-blowing moments where all of a sudden the bath bomb just makes sense to them. I want to urge you to provide moments for students to explain it to each other and really watch their faces for those aha moments. That can be so rewarding for us as teachers and makes the next lesson a breeze.